I want you to just picture your browser right now. I mean, be honest. How many tabs do you have open?
Oh, I don't even want to think about it.
You've probably got, what, 3 or 4 PDFs you downloaded last week and swore you'd read?
Mm-hmm.
A 2-hour YouTube lecture you're supposed to be watching for a project? And just like a scattering of notes in a Google Doc that make no sense.
You are describing the universal state of the modern knowledge worker. We're all drowning in information, but we're absolutely starving for actual insight.
Exactly. And the first reflex is to just grab all that chaos and shove it into a chatbot.
Right.
You paste it into ChatGPT or Claude, and you say, please just tell me what this means.
But then you get that feeling.
Yes, that pit in your stomach, the hallucination fear.
The hallucination fear. Is it making this up? Is it pulling facts from some Reddit thread from, 2014?
Because standard chatbots, they're improvisers. They want to give you a smooth answer, even if it's not, strictly speaking, the truth.
And that's the core problem with large language models trained on the open web. They're built to predict the next word, not necessarily the correct fact.
Well, today, we are unpacking a tool that claims to solve exactly that. We're doing a deep dive into Google's NotebookLM.
Mm-hmm.
The pitch is that it's a personalized research assistant. But based on our source stack for today, which includes a medical study from Japan that is, frankly, mind-blowing, and a security paper that's, well, terrifying. This isn't just another chatbot.
It really isn't. NotebookLM, it sort of represents a fundamental shift in how these AIs are built. We're moving from search to synthesis.
And the key to all of this is something called source grounding.
Source grounding. Yeah.
It sounds like a punishment for a teenager.
In a way, it is. It's a punishment for the AI. You're restricting it. When you use NotebookLM, you are effectively putting blinders on the model.
So it forgets the internet.
It forgets the open internet, it forgets what it thinks it knows about the world, and it only knows what is in the documents you feed it.
So if I upload a PDF about, say, the mating habits of beetles,
Right.
and then I ask it about the French Revolution, what happens?
It just tells you, I can't answer that based on the sources provided. It doesn't guess. It won't improvise.
Okay, that sounds great in theory, but we need to know if it actually works better than the big guys, like GPT-4.
And for that, we're looking at a study from the University of Yamanashi in Japan.
This is the one.
This study, led by Ryota Tezuka, it's the perfect test because they chose a field where hallucination isn't just annoying, it could be fatal.
Lung cancer staging.
Exactly, lung cancer staging.
Yeah, this isn't writing a poem. This is determining if a patient has, stage T2A or T2B cancer.
Mm-hmm.
Binary. You're right or you are wrong.
And if you're wrong, the patient gets the wrong treatment. So what they did is they created a data set of 100 fictional patient cases.
Okay.
Just text descriptions of CT findings. And they fed these cases to different AI models to see if they could correctly stage the cancer.
And here's the crucial part, right? They didn't just ask it to guess. They gave it the rule book.
The official lung cancer staging guidelines, they call it Reliable External Knowledge, or REK.
Which is just a very fancy way of saying the textbook.
It's the textbook, yeah.
So let's look at the scoreboard. First up, GPT-4o, the heavyweight champion. They asked it to stage the cancers without the rule book, just from its training. How'd it do?
It was a disaster. 25% accuracy. It was basically guessing.
Okay, but that's not fair.
Yeah.
So they gave it the notes, they uploaded the rulebook to GPT-4o. Did it get better?
It did, but not by much. It only went up to 39%.
That is shockingly low, 39%, with the rulebook right there.
It really highlights a weakness in standard LLMs. Even when you give them the rules, they kind of struggle to apply them strictly. They get distracted by their own internal data.
So it might remember some old guideline it saw somewhere.
Exactly, or a forum post. And it mixes it all up.
And then they ran the same 100 cases through NotebookLM.
And NotebookLM got 86%.
86. That's a massive gap.
Mm-hmm.
We are not talking a few percentage points here. We're going from 39 to 86. Why?
It all comes down to that grounding architecture we mentioned, specifically something called RAGO.
Right.
Retrieval-Augmented Generation. Think of it this way. GPT-4o is like a student who thinks they've memorized the book.
Okay.
When you ask a question, they recite from memory. NotebookLM is like a student taking an open book test who doesn't trust their memory at all.
So it's looking up every single answer.
Explicitly.
Yeah.
In the study, they found it had a 95% search accuracy, meaning it found the exact paragraph in the guidelines that applied to the case.
And that leads to the feature that I think is the real game changer here.
Yeah.
The citations.
Yes. So when NotebookLM gave a diagnosis, it didn't just say it's stage 2.
Right.
It said it is stage 2 because of this rule, and it gave a little clickable citation number.
So the doctor checking the work doesn't have to trust the black box. They can just click the number, see the highlighted text in the original PDF, and verify it instantly.
That verification loop is everything. It turns the AI from an oracle into, a tool.
But we have to be balanced. The sources did mention a specific weakness.
Right. The math problem.
The math problem.
It still struggles with numerical comparisons. So if a guideline said tumor greater than 3 centimeters and the patient's was exactly 3.0, it could get confused.
Which is a good reminder. These are language models, not calculators.
Precisely. So keep your calculator handy. But for a tool that was built in just 6 weeks, it was originally called Project Tailwind at Google, that accuracy gap is it's huge validation.
Okay, let's pivot from the medical lab to the laptop screen. Because most of us are not diagnosing cancer, we're trying to understand a 50-page contract.
Or study for a history exam. And the user experience for NotebookLM, it's getting a lot of praise for being really minimalist.
It is. I opened it up and thought, where are all the buttons? It's just 3 panels. Sources, chat, and your notes.
And that simplicity is deceptive because of what you can put into that sources column. We know about PDFs, Google Docs.
But the one that surprised me was audio. You can upload MP3s.
And YouTube URLs. This is huge. Imagine you're a student who missed a lecture. Or there's a conference panel with no transcript.
You just paste the link.
You paste the link, and it digests the spoken word just like text.
So you can have the video questions, like, what did the second panelist say about renewable energy?
Exactly. No more scrubbing through the timeline.
But speaking of audio, we have to talk about the feature that is probably the most meta thing happening in tech right now.
The audio overview.
A deep dive generator.
Yeah.
You upload your boring documents, quarterly earnings reports, biology notes, whatever, and you click one button. And NotebookLM generates a podcast.
A fully produced, two-host conversational podcast about your specific data.
It's basically us, but AI.
It is us. And what's fascinating and maybe a little unnerving is the quality. It's not a robotic voice. They banter. They interrupt each other.
I read a user review. Someone uploaded a 20-minute recording of a chaotic work meeting. They said the AI summary didn't just get the action items, it captured the emotion of the room.
That's the Gemini 1.5 Pro model underneath. It understands tone. And there was just a recent update that takes this even further.
What's that?
You can now direct the hosts. You can interrupt them and type, hey, focus more on the financial risks, or explain this like I'm 5, and they'll pivot the conversation in real time.
Wow. If you're an auditory learner, you don't have to read the 50-page PDF anymore. You can just listen to 2 smart people explain it to you on your drive to work.
It's democratizing access. But there's another new feature that pushes this from study tool into research agent.
Okay, this is the deep research feature, right? This is the one that steps outside the walled garden a little bit.
Correct. Until recently, it only knew what you uploaded. Now you can give it a topic, say the history of espresso machines, and it acts as an agent. It goes out, browses hundreds of websites, filters the junk, and builds a knowledge base for you.
So it builds the source stack automatically.
And then writes a multi-page report citing those sources. It automates that initial, drudgery.
Which brings us to the how-to part of this, because we have listeners who want to know, okay, this is cool, but how do I use it to get smarter?
We found some fantastic workflows from a source called The Effortless Academic. These are basically cheat codes for researchers.
I love these. The first one that jumped out was the Gap Hunter.
This is brilliant. Let's say you're researching remote work productivity. You upload 15 different PDF studies, articles.
And usually you just ask for a summary.
Right, which is boring. Instead, you use the Gap Hunter prompt. Identify the methodological, theoretical, and empirical gaps in these papers.
So you're asking the AI to tell you what the experts missed.
Yes, it synthesizes everything and says, hey, study A looks at tech workers, study B looks at creatives, but nobody's looked at manufacturing managers. Boom. You have your thesis.
It saves weeks of reading.
Easily. Another great one is the contradiction finder.
I need this for my daily life.
You just ask it, where do these sources disagree? It'll scan them and highlight conflicts. Source A says coffee reduces heart disease risk, but source B says it increases hypertension.
That's critical thinking in a box. It forces you to see that the true isn't always settled.
It prevents you from cherry picking. And for, say, historians or legal teams, there's the timeline feature. You ask it to trace a concept like data privacy law from 1990 to today.
And it just extracts the dates and